Inside our massive data centers, our factories, even the electrical panels in our own homes, there's this unseen backbone doing all the heavy lifting. They're called busbars, and you can think of them as the superhighways of our electrical world. So today, we're going to pull back the curtain on the incredible, mind-boggling precision it takes to manufacture these absolutely vital components.
Okay, so let's get on the same page. What exactly is a busbar? Well, it's basically a solid metal conductor. But don't think of a flexible wire. No. This is a rigid, powerful conduit that's designed to distribute massive amounts of current safely and super efficiently. It's really the central nervous system for any serious high-power electrical system.
And make no mistake, this isn't some tiny, niche market. We're talking about a global industry that's projected to be worth over $20 billion by 2027. I mean, that incredible growth is a direct reflection of our world's absolutely insatiable appetite for electricity.
So, here's our game plan. We'll start with the foundational materials, what these things are made of. Then we'll dive into the really high-stakes hurdles of manufacturing them. From there, we'll check out the modern tech that makes it all possible, talk about the relentless pursuit of perfection, and finally, we'll take a peek into the very smart future of fabrication.
All right, so where does it all begin? Well, the performance of any bus bar really starts with its raw material. And right out of the gate, engineers have to make a really fundamental choice.
This table, it tells a really clear story. On one hand, you've got copper. It is the undisputed champion of conductivity. That's how well it carries a current. But look at that density. It's also over 3 times heavier than aluminum. This creates a critical decision, right? Do you go for the pure, raw performance of copper, for say a massive data center, or do you opt for the weight and cost savings of aluminum in something like an electric vehicle where every single gram counts? And that choice, that's just the very beginning. Once a material is picked, fabricators face this immense challenge of shaping it with near-perfect precision, because even the tiniest little mistake can have absolutely massive consequences.
This number right here, this is everything. We're talking a manufacturing tolerance of plus or minus 1/10 of a millimeter. That is about the thickness of a single sheet of paper. Any deviation, anything at all beyond that, and the bus bar simply won't fit correctly. That compromises the safety and the reliability of the entire system. It's that serious.
And this is what happens when that precision fails. Bending a thick piece of metal might sound simple, but it is incredibly complex. Getting that bend radius wrong, just a little bit off, is a factor in over 1/3 of all bus bar failures. It creates these invisible stress points that can lead to catastrophic cracks over time. So here's a perfect example of why bending is so tricky. It's called the spring-back effect. Imagine you bend a thick piece of copper to a perfect 90-degree angle. The moment you release it, the metal's memory kicks in and it springs back a few degrees. So fabricators have to calculate this perfectly and actually overbend the material by just the right amount to compensate. It's a true blend of science and art.
Now, joining sections of busbar together, that's another huge hurdle. And this data from Siemens is just staggering. A single bad weld can crank up electrical resistance by 400%. That resistance generates an incredible amount of heat, creating a super dangerous failure point and dramatically shortening the system's lifespan.
Okay, so the stakes are clearly sky high. How in the world does the industry overcome these challenges? Well, the answer lies in a really powerful toolkit of modern automated technology.
Just look at the night and day difference between the old manual methods and today's CNC processes. CNC, that's computer numerical control. It's basically using a computer file to tell a machine exactly what to do, perfectly, every single time. And with it, setup times just plummet, errors are virtually eliminated, and you waste way less material. Automation directly tackles those core challenges of precision and consistency we were just talking about.
And to put that into perspective for you, industry leader Rittal AG, they used to spend 45 minutes setting up their machines for a new product run. By switching to modern CNC systems, they slashed that changeover time down to just 6 minutes. That is a massive leap in flexibility and efficiency. And that efficiency gets another huge boost from integrated machinery. These modern 3-in-1 machines, they take a raw bar of metal and perform all the core steps, cutting it, punching the holes, and bending it, all in one seamless automated workflow. It's a total game changer.
So when you put it all together, the results are just wow. We're talking about errors being reduced by nearly 90%, overall production throughput jumping by 45%, and with advanced welding techniques, joint reliability can hit an incredible 99.7%. This is the power of precision technology at work. But listen, the best machine in the world is only part of the story. Achieving true perfection also requires absolutely rigorous quality control and, maybe most importantly, a highly skilled workforce. Let's see how these pieces fit into the puzzle. This is not just a quick visual check at the end of the line. No way. The top manufacturers use a multi-layered defense against any defects. They analyze the metal's exact composition before they even start. They use high-tech coordinate measuring machines to verify every single dimension. They test the electrical resistance of the joints, and they even use ultrasound to find internal flaws that are totally invisible to the human eye.
And this approach, it is incredibly effective. By using something like automated ultrasonic inspection, a company like Mitsubishi Electric can achieve a near-perfect defect detection rate of 99.9%. They're finding tiny flaws that would be absolutely impossible to catch otherwise.
And here's the crucial point. This isn't about replacing people with robots, it's about empowering them. A machine can follow instructions perfectly, sure, but a skilled technician understands why. They can interpret the data, troubleshoot complex systems, and make sure the entire process runs flawlessly. And the data proves it. Companies that invest heavily in training their people see a 34% lower defect rate. The best tech paired with the best people, that's the winning formula.
And this combination of human expertise and incredible technology, it's evolving faster than ever. So let's look ahead. Let's see how Industry 4.0 is getting ready to completely transform the world of busbar fabrication. What we're seeing is a remarkable acceleration. Right now, factories are embedding IoT sensors everywhere for real-time monitoring. Very soon, all that data is going to fuel predictive maintenance, which could cut machine downtime by up to 70%. A little further out, we'll see digital twins, perfect virtual copies of the entire factory that allow for constant optimization. And by 2026, many experts predict that AI-driven quality control will just be the industry standard.
Which, of course, leaves us with a really fascinating question. As all these smart technologies move us closer and closer to eliminating human error and material imperfection, will perfect fabrication just become the new baseline? And when perfection is the standard, what new frontiers of efficiency, power, and possibility will open up for the unseen backbone of our modern world?